Hi everyone, I am Mahesh. In this video, I am going to show you how to generate Fibonacci series. First of all, let us understand what Fibonacci series is. In Fibonacci series, the first two terms are 0 and 1. And from there, to calculate the next term, what we do is we take the sum of the previous two numbers. So here in this case, the previous two numbers are 1 and 0. So the sum of 1 and 0 is 1. Next term. How do we calculate the next term? Again, the sum of previous two numbers. That is 1 plus 1, 2. Next term, 2 plus 1, 3. 3 plus 2, 5. 5 plus 3 is 8. Next 13, 21, 34, 55, 89 and so on. This is what we call as Fibonacci series. Now let us see how to actually write the logic for the same. So the first term we call it as T1 and let us call the second term as T2. First term, let us call it as T1 and the second term we call it as T2. So in this case 0 points to T1, T1 points to 0 and T2 points to 1. Now let us see how to generate this series. So for that, what we'll do is, as we wanted to display all the numbers in this series, first as the first term is denoted with T1, let's display T1. Then what we'll do is, we need the sum of the previous two numbers, right? So we'll take up the sum of the two terms. Then we'll assign T2 to T1. As we wanted to, in the next iteration, we wanted to display T1. So we'll take the T2 value and assign it to T1, and then T2 will have the sum which we calculated in step 2. Now let's actually look into it, how it works. So in the first case, it display T1. So it displays first of all 0. Then what happens? Sum equal to T1 plus T2. So T1 plus T2 is 1. So the sum is 1 now. Next, T2 is as in T1 is as in T2 value. So T1 becomes 1 now. T2 is as in the sum of T1 and T2 which we calculated in step 2. So it also becomes 1. Now we'll go back to the step 1 again. This time what is the T1 value? You can see it here. T1 value is 1. So we'll actually display 1 here, and then sum. Sum is T1 plus T2. T1 is 1 and T2 is 1. So sum becomes 2. T2 value should be assigned to T1. What is T2? T2 is 1. So we will not change that. We'll keep it as is. What is sum value? 2. So we'll change this value. So T2 is 2 now. Again we'll go back to the step 1. Display T1. T1 is, you can see it here, it is 1. So we'll display 1 again. And then sum is T1 plus T2. What is T1? 1. T2 is 2. So sum becomes 3. We'll assign T2 value to T1. T2 is 2. So we'll assign 2 to T1 now. Sum is assigned to T2. What is sum? 3. So T2 value is 3 now. Again we'll go back to step 1. Now we need to display T1. What is T1? 2. So sum becomes this time T1 plus T2. So 2 plus, so T1 plus T2 is, T1 is 2, T2 is 3. So sum becomes 5. T2 value is 3. So we'll assign T1 as 3. Then sum we need to assign it to T2. It becomes 5. And if you observe, then we display T1 value, so 3. And if you observe, we are slowly generating the Fibonacci series as seen here. So this process will follow until like given value of n. So given an value n, we wanted to print n terms in Fibonacci series. So we'll take a loop, and we'll iterate it for n times. So for n iterations, we'll actually do this process. And now let us write a Java program for the same. Let me name this class as Fibonacci series. Let us take n value as some first 5. We'll start it with 5. Then T1 is just term 1, 0. We'll assign it is first term, so we are assigning 0, 1. The first two terms in the series are 0 and 1 that we discussed. Then from here we'll start, and we'll take variable sum. Okay, we'll take it inside the loop. We'll start it from 1, and we wanted it to run it for n times. So I less than or equal to n. So this loop iterates for n times. What we wanted to do first, we wanted to display. According to this, whatever we discussed, we wanted to display. To display output on console, we use system.out.println, and we'll display T1. We'll leave some space. Then we'll calculate sum. What is sum? Sum is T1 plus T2. Then we'll assign T2 value to T1. Then T2 will take the value of the sum, new sum. That's all. This loop will iterate for like n times, so that we'll get like n terms in the series. Print n terms in series. You can see here, each time when we enter the loop, first thing what we do is we actually print the T1. T1 will have the current term value in the series. So we'll always denote the number in the series with T1. So T1 is displayed. Then we'll write this logic so that we'll get the next term in the series, which will be assigned in T1. And this loop continues for n times, as we wanted to print n terms in series. Now let us execute this and verify. And we can clearly see here, we got like first 5 terms, 0, 1, 1, 2, 3. We can actually use print method instead of println, so that all the entire series comes in one line. You can see it here. These are the 5 terms we wanted to print. We can actually try to print 10 terms even. We can see here, these are the first time 10 terms in the series. Likewise, we can print n terms in series using the same logic. Now let us try to print uh, all terms in series which are less than a given number n. So print series less than a given number. And for that, what we are going to use is, we are going to write a loop, and we'll have the same logic. We just wanted to print all the numbers less than n. So this time we don't wanted to have a variable which will actually be used to count the iterations. But what we wanted to do is, we wanted to actually have a condition on the term. So the term in the series is denoted with T1, as we discussed earlier. So this T1 has to be less than or equal to n. Till this time we wanted to print the series of numbers. So in the earlier case, we know like we wanted a fixed number of terms in the series, like 10, 15, 5, like that. That number of terms we wanted to display in the series. Here it is different. We are given a number, and we wanted to print the series of numbers which are less than this number. Till that time we wanted to print all the numbers in the series. And how do we do that? We know that we are actually representing our term with T1. So we'll actually use that, and then it has to be less than or equal to n. Till that time we'll print all the terms in the series using the same logic. So for this, let us write like this out. terms less than n. We can see here now. So we give value 10. Now let us see here. And we can clearly see here terms which are less than 10 are, it starts with 0 and it ends with 8. It doesn't display 13 as 13 is greater than 10. So we can even give it like 100. So all the numbers in the series which are less than 100. So you can see it here. It stops at 89. As after 89, the value is like almost 144. So it doesn't display that number as it is greater than 100. So all the terms which are less than 100 are displayed here using the same logic. So here we are not using for loop, as we don't want to, as we don't know like how many iterations this has to be looping. So we'll be using the condition T1, which is the term we wanted to actually display in each iteration, and this has to be less than the given value n. So we are using this, and we are using while loop here. Next, we wanted to print nth term. So we don't wanted to print all the terms in the series, but given a value n, we wanted to print the nth term. So for that, again, what we'll do is we'll use the same logic as the first logic. But if you observe here, we don't want it to print each term, so we'll comment it out. But if you observe, each time when like for the first term, first time when we enter into this loop, T1 is displayed. So the first term is displayed. And then what we are doing, if you observe, T2 is assigned to T1. So we are changing the value of T1 to T2, so that in the next iteration, the next value of the term will be displayed. So if you observe, for the first time when we enter into the loop, T1 is displayed, fine. But the second term is also assigned to T1. So in the first iteration, T1 is assigned end of the loop, before just end of the loop, T1 is assigned the value of second value, second number in the series. Next, if we take I as 2, like in the second iteration, it will have the third value. In the third iteration, it will have the fourth value stored in T1. Likewise, if it is like a ninth iteration, it will have 10th value. If it is n minus 1 iteration, it will have n value. So what we are going to do is, as we wanted to print nth term, we will actually loop it only n minus 1 terms. So I am removing equal to here, so that it will only loop n minus 1 terms, so that T1 will have nth term. So here we can say like nth term in the series is, we are denoting it with T1. So we'll just display T1 here. Now we can verify. So nth term, let's say for example, let's start with 5. You can see here fifth term in the series is 3. We can count it here 0, 1, 2, 3, 4. So 1, it should, sorry, the index like we wanted to actually start with 1, right? First term 2, 3, 4, 5. So fifth term in the series is 3. Now we can also verify like 10th term. Let's verify 10th term. So 10th term in the series is 34. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10th term in the series is 34. So this is how we can actually display nth term in the Fibonacci series. And these are the three different, we can't call it as three different ways, but three different approaches or three different problems in Fibonacci series. Like first one, what we saw how to print n terms in the series. Then we saw given a value n, we wanted to print terms which are less than n in that series. And at last we wanted to print only the nth term. This time we don't wanted to print all the numbers in the series, but given a value n, we just wanted to print the nth term in the series. That is what we have seen here. So that's all for this video. Thanks for watching.